Hey everyone, and welcome to your first video for Algebra 2. We're going to start with lesson 1.02. This should be on page 3 of your notebooks. So the page before this should be the second page of today's notes with quadratic tables. So we're starting with solving quadratics by factoring. Page 3, lesson 1.2. Make a space for your thinking questions. We will have one every time we do a think aloud. Our first example, solve for x. For negative 6x cubed minus 3x squared plus 18x equals 0, and then a spot for the evaluation steps. You can pause the video now to take 1 minute to organize your notebook. Great. So we are going to do a think aloud today. I know you are very familiar with think alouds from geometry, but just to remind you, during the think aloud, you are responsible mainly for 3 things. The first thing is you are listening to everything that I'm saying. The second is you're writing down all the notes that I write down. And the third is the thinking question. Listening for and capturing that thinking question right here in your notebook, or in the designated area for your thinking question. So as we begin, I'm going to be asking myself a ton of questions, writing down a ton of notes, and going through a ton of processes that I would do for every problem that I do, like this problem. At any point in the video, feel free to pause, rewind, or recapture something that you were unsure about. But we are just going to go right through this video, and I'm going to talk as if I'm alone, thinking through this problem, exactly how I would do it. And we are going to begin. So I need to solve for x for negative 6x cubed minus 3x squared plus 18x equals 0. So I need to solve for x. That means I need to somehow isolate the x value in this equation. So I need to isolate x. So how can I use the structure of this equation to solve for my unknown variable? How can I use the structure of this equation to solve for my unknown variable? Well, looking at the structure of this equation, I see here that I have a function with a degree of 3. And I'm not really sure exactly how to solve for x when my degree is 3. But I do see that between each term of negative 6x cubed, negative 3x squared, and 18x, I do have a GCF. So I'm going to first take out my GCF. And I know whenever I take out a GCF, I always want to do coefficients and variables if possible. So when I look at each term, I can see the coefficients are negative 6, negative 3, and 18. And I all know they have 3 in common. And then between my variables, I see that x cubed, x squared, and x are with all the terms. So all the terms have at least an x to the first power. So I know that whenever I'm finding the GCF of variables, I always use the variable with the lowest power, or the lowest degree. So x would be my lowest degree. And because I can see that the leading coefficient is negative, I'm going to make the GCF negative to make that leading coefficient positive. I know if I divide a negative by a negative, it'll make it a positive. And having a leading coefficient that's positive will make this problem so much easier for me in the long run. So I'm going to take out that GCF, negative 3x, and that'll leave me with 2x squared plus x minus 6 equals 0. Great. Now, how can I use the structure of this equation to solve for x? Well, now that I've taken out that negative 3x, I can see here in my new equivalent form that in the parentheses, I have a quadratic function. Now, I know it's quadratic because it has a degree of 2. It's the highest degree. And that means that if I'm solving this, I can factor it, because I know that if I'm solving a quadratic function, I can factor them. So I can use the structure of this equation to solve for x by factoring. But what method of factoring am I going to use? I know I have 3 different methods of factoring. So in order to determine which method I'm going to use, I'm going to identify A, B, and C. I know A is always in front of the squared term, so that would be 2. B is always in front of the degree of 1, so it'll be a 1. And C is always the constant, so it's a -6. So looking at this, I can see that because A is greater than 1, I'm going to use grouping. I'm going to factor by grouping. And that's because this A term is greater than 1. Great. So I know that the first thing I need to do for grouping is I need to to find my factors. Or to find the 2 numbers, I need to find my master product and my sum. The master product I know comes from multiplying A times C, so 2 times -6, which gives me -12. The sum is the B value, which is 1. So now I need to find 2 numbers that multiply to -12, but add to 1. And that'll be my... So the 2 numbers that multiply to -12 and add to 1. Well, I know 1 has to be positive and 1 has to be negative. So I think 6 and -2, but that won't give me 1. -4 and 3, that'll give me -1. What about 4 and -3? Well, if I do 4 and -3, I know that'll give me -12. If I add 4 and -3, that gives me 1. So I'm going to use 4 and -3. I want to do my next step, which is a little bit more complicated than my previous steps, but still pretty simple. I'm just going to take these 2 factors that I found, and I'm going to replace the B term in my quadratic with these 2 factors. So we're going to replace B with factors. So I'm just going to put an orange box around this because I'm using orange. Because this is the only thing that's going to change in this next step. So in step 4, the only thing that should change is this term. So I can rewrite everything exactly the way it is. So I'm going to have -3x on the outside. I'm going to have 2x squared. But instead of positive x or plus x, I'm going to rewrite that as 4x, so plus 4x, minus 3x. And then -6 equals 0. This allows me now to group because I have even amount of terms. So I can group 2 and 2, and then I can finish my factoring. So all I did was replace this term with these 2. Because if I combine like terms, 4x minus 3x, it'll give me that 1x. So this is still an equivalent expression. These are equivalent. It's just we're rewriting it in a way to make it easier for us to factor. So now that I have replaced my B value, we're going to move on to our next step, which is to actually group where factor from grouping comes from. So now that we have 4 terms, 1, 2, 3, 4, terms are divided by plus and minus signs. I have 4 terms I can group. Group terms. I always do the easiest thing for me is to group my first 2 terms and my last 2 terms. Now, once I've grouped my terms, I'm going to factor out a GCF from each pair. So this is my first pair and my second pair. So I'm going to find the GCF of each pair. So for 2x squared and 4x, I can see that the GCF here is going to be 2x. So I'm just going to rewrite that -3x over here because it's still part of my function. I'm going to use brackets since I'm going to be using parentheses also. And I'm going to say the GCF here is going to be 2x, which leaves me with x plus 2. Now, my goal is to take out a GCF here and to be left with x plus 2. So when I look at -3x and -6, how can I use the structure of this binomial to factor out a GCF? Well, I can use the structure of this binomial because I can see that -3 and -6 have 3 in common. So I can factor out a 3. But I need this to become x plus 2. So if I just factor out a 3, it becomes -x minus 2. But if I factor out a -3, it'll be x plus 2. And that's exactly what I want. I need these 2 values, these 2 binomials, to be the same. Because now I have a common factor between these 2 terms. So between 2x times x plus 2 and negative 3 times x plus 2, they have x plus 2 in common. And then equals 0. So now that I've taken out the GCF for each pair, I can rewrite factor pairs, or rewrite the factors. So because they have x plus 2 in common, x plus 2 is one of my factors. X plus 2, negative 3x is still on the outside. We cannot lose it. And then the other factor comes from, after we take out x plus 2, we're left with 2x minus 3 equals 0. But I'm not done. I factored, great, but this problem didn't ask me to factor, it asked me to solve. So I actually have another step that I need to complete, and this is my final step, and that's to, oops, I don't want to write that in the same color, let's do purple. Set each factor equal to 0 and solve. So we know from algebra 1 and geometry, we have something called the zero product property, which means if I'm multiplying and 0 is my answer, at least one of these values has to be 0. So what I need to do is set each one equal to 0, because any one of these could be 0. So anything with a variable, or anything with an x, gets set equal to 0. So negative 3x, because it has the x, we're going to set that equal to 0. X plus 2 gets set equal to 0. And 2x minus 3 gets set equal to 0. Because they all have an x. So now I can just use inverse operations. Solve using inverse operations. IO stands for inverse operations. And we can just solve this really quick. So I solved these two problems. Cancel, these cancel to 0, this cancels to 1, this cancels to 0, this cancels to 1. So now that I've solved these, I have 3 solutions. I have x equals 0, x equals negative 2, and x equals 3 over 2. And I've solved for x, for this specific function. Great. Think Aloud over. Thanks, guys, for participating in the Think Aloud. And if you have to, please feel free to rewind, rewatch, or whatever you need to do. See you guys in class.